Hope you can hear me. So now we are starting next week, but we have few things like I would like to discuss from the previous 2 weeks. One thing is from domestic wastewater treatment and municipal wastewater treatment. So you guys can hear me. Can anyone reply? So can anyone reply? Can you hear me? Okay, this week we I will solve few questions also, so you have to respond. So you guys have a calculator. Can you hear me? Can anyone can reply? Okay, I'm starting the lecture for the week 3. So anyone from the previous class joined? Anyone from the previous class of mine has joined this class also? Please raise the hand. Okay, so nobody is responding. I'm starting the lecture. So what is the difference between domestic wastewater treatment and municipal wastewater treatment? That was the question asked by a student. So now we are going to see a few things, few points from both of that. So first of all, domestic wastewater treatment. So that we have seen that it is mainly from the home. So that is we have seen that is mainly consists of the toilet, kitchen waste, and also there is cloth. From the washing of clothes there will be like discharge of water, and also showering. So the from these toilet and dishwash and kitchen singas called as unitely called as black water, and the other is gray water. So the doubt was the difference between a municipal wastewater and what is the difference of municipal and domestic wastewater. So that's what the question from a student. So to clear the doubt, I would like to discuss these things, what the different wastewater sources, that is municipal wastewater, industrial wastewater, agriculture wastewater, and stormwater. And here we have discussed already about domestic wastewater. So what is the difference here? The municipal wastewater, when we consider, you can see from this figure, it's considering the whole municipality. So that means there is a waste from, you can see here on the screen, waste from home, that is the, that we already discussed, that is the domestic wastewater, that is mainly from the kitchen, toilet, and also the washing of clothes and other activities. These all things are there. Apart from that, in the municipal wastewater, there is also the wastewater which is from the different other buildings which is in the municipality. For example, here in the figure you can see the saloon, right? So in the figure you can see the saloon, and also there is other big laundry buildings, and there is hotels will be there. Apart from that, there will be educational institute, then hospitals. From these all things there will be wastewater which is generated, and small scale industry, small scales. So these all water collectively call as municipal wastewater. In the municipal wastewater itself, domestic wastewater is there, that is the waste from the home. Then other than the home, there is other wastewater like from the saloon, from food industry, from the hotels, from the hospitals, and these all things collectively called as municipal wastewater. Okay, so then what is agriculture wastewater? That agriculture wastewater is the waste which is from the agricultural feed. That mainly happens when, you know, these the different pesticides that we have applied to the agriculture fields, these all things will come into the big amount of water in the rainy season. Other than that, they will be other waste, like it will some of the agricultural feed will get, you know, spoil, and that will degrade. That waste will be there. And also there is a, you can see in the figure, there is a turbidity you can see in the water, that is the turbid water from the agriculture field. That means there is a lot amount of the soil and the particles which is in the soil is dissolved in the, you know, merged in the water and make it more turbid. That is agriculture wastewater. So when the storm water from this figure you can see in here, see it's a place, and you can see different buildings are there. And there is also, you can see a storm water which is from the rain. So when it's rain, this water will pass through different regions of this place, and these water collectively come and it become a big reservoir, and then this water will can enter into the sewage water facility also. So that is, you already have seen the third week lectures, in that you have learned about infiltration. So you guys can hear me, at least someone can respond. Okay. So this till here, any doubt is there? You guys got to know, completely understood what is the difference between this here, what I have told about municipal wastewater and domestic wastewater. Hopefully you guys got to know domestic and municipal wastewater has difference. And the differences in the municipal wastewater, there is a huge collection of other building, other institutions also, which together contribute for the huge amount of wastewater, that is the municipal wastewater. Okay, now in the previous class we have learned that the importance of getting to know different, you know, the number of population. So the number of population for the future we can predict by different techniques. Now we have learned about two techniques, arithmetic increment method and geometric increment method, and the third one that we should know for solving questions are incremental increase method. So, incremental increase method, that means the assumption is growth rate is progressively either increases or decreases. For some part of time, it will increase and then it can decrease. These case studies can, you can take a city or the place and you can compare it with the other cities which has the same type of facilities, same type of mode of development, and you can predict that the population increases for certain time period and then decreases. So you can collect a huge number of database from different places and analyze the places how the population can grow. So how can we predict the number of people for the future by this method, incremental increase method. So now we see what is incremental increase method. So for understanding the incremental increase method, we can solve this particular problem. Okay. So if you guys have some paper, please write it down and take a calculator or Excel. You can do it quickly. So the year here it is mentioned from 1961 to 2011. So then the population is in the next column you can see the population, and the third column what you have to do is you have to calculate the difference between the two years. Okay, let me first tell you, show you how. See here, here you have to write the difference between the final and initial. Okay, so you have to always go from backward. So you have to calculate this value increase from, taking the difference from subtracting this value from here, that is backward you have to go. Then here you have to calculate from this value to this value. So it is like you have to go from backward to forward, the backward you have to go. So I will show you how you have to do. So you, if you can also take some paper and write it down. So this method you guys know, already have learned. Yes, okay. So you guys can write it down here. So this is first 1961 to 2011. So the increase value you have to note it down, like here 1971 what is the value, 1015,672 minus the upward value, like that you have to do. Okay, you got it now. So you have to always, like you have to people in 1971 minus people in 1961. Then after that you have to calculate people in 1981 minus people in 19. Okay, you can't see. Okay, now it's visible, right? Okay. Yes. Okay, so you have to take the difference. So always you have like this. Go like this. So then this particular column will fill that one. So you guys found? Got it? So I will write the numbers here. You can just see and tell like whether you got the correct like this answer or not. Okay, I'm not able to write it. Okay, so here I will write. So the first value you got this one, 157127. Huh? right? Next value 185,881. Got it? Then 489985. Next value 386282. Got it? Anyone can see the screen? Everyone, you people are solving, right? The question. Okay. So you people can respond. So it will be helpful. We can solve quickly and we can go for the next question. Okay. After that, it will be 508042. So here, basically what you are doing is you are taking the difference from here to here. So final minus initial, final minus initial. So like that you are calculating and you are filling, filling here, they increase. Okay. Okay, here I'm able to do it. You can see the screen. If anyone can't see the screen, please let me know. I will. Okay, in between there was some network connections issue was there, so that's why it get cut off. So everybody's there. So I will go to this and I'm writing this. If you can't see the screen, please let me know. 489985. And here, yes. Okay, you can't see the screen. Let me see. So now, can you see the screen now? Okay, okay, thank you. Thank you for responding. Okay, now, yes, yes, yes. Okay, 13 and yeah, which one is that problem only? Actually, I don't understand that much. You can talk like this only in English. Ah, ah, okay. So which answer, like, can that question we discussed in the class, or? Okay, okay. So that is like you have like the question that I have taught you, that only you have doubt, right? Okay, okay. Yeah, that we'll discuss that one at the end of the class so the other people can leave and we can talk. Yes. Is that fine? Okay, okay. So that is also the population thing only, right? That arithmetical increment method or geometric increment method, right? That one only. Okay, yeah, that we discuss. Yes, yes. So this is the third one. Like that is like the two types we have discussed in the previous class, and this method, which is incremental increase method, is the third method, in which the assumption is the rate of growth can increase or decrease. So this is like third one. So we'll come back again to first and second at the end of the section. Okay. Yes. Right? Okay. So now we'll go for the third method in which I am discussing here. So in this method, I have given the question. By solving this, we'll understand this method. So till from 1961 to 2011, the population is given. So what we have to do is we have to calculate the difference between the population. That means here the initial minus final you have to take. So don't do like from here forward, then you get negative value. So first you would have to do backward. So here positive and negative value actually matters here. So you have to do it like backward only. So now what you have to do, you got this and you can fill this. So if you have then excel, it will be easy. So you got all guys, I think everyone have solved this column. Have you got it? So is this the same answer that you guys got? Okay, thank you. So next what you have to do. So okay, here. Uh, so what you have to do, you have to total. So you have to calculate the total value. So the total value is here 1727317. Then what you have to do, you have to take the average. So when you take the average, sum and divided by 1, 2, 3, 4, 5. So then average value you will get like 345463. Okay. So now you people do like this. Again, you have to do backward like subtraction. You have to minus from the final value. This is the final and this is the initial. And here this is the final and this is the initial. So like this, backward you have to do the value you have to calculate, and you have to write it with the sign. So if it's plus, you write it plus. If it's minus, you write it minus. So do it like done. Yeah, you can take like, if you have excel, then so here you have to do like backward, that is 1858881 minus 157127. Then again this value minus this value, this value minus this value. So here, if you do it, you will get first 28754, then 304104. Here, see here, this is 3,86,282 minus 4,89,000. So this is smaller value. So you get 103703. Then 121760. Then you have to calculate again the total. So you have to add this all. You have to take the summation, and the value you will get total 350,915. Then you have to take the average of these four values. The average value is 87729. So this is your basic analysis that you have done from the year 1961 to 2011. So this basic, yes, which one? Why, right? Yes, yes. This one. Yeah. Okay. Yeah, you what you are getting is like what? Yes. You tell me that 8. Huh. So yeah, yeah, you just rounded it. So yes. So you can take like a 8 to yes. Yes. So that is decrease in here. So you so yeah, decrease is there. Yes. So the popular, yes, yes, tell me. Yeah. Huh. See here also in population, you when you see the population, yes, you see that it is first increasing. Then after 90, yes, till here it has increased. No. So here it is continuous increment is, yes, in the rate. That is the rate. This only, this X. This one. Yes, yes. Or decrease, it can in the same year. See here in the I think in the first examples we got everything was increasing. I hope so. Here you see that it is increasing till here, and then it started decreasing it, and again it is increased. Yes, so there is increasing decreasing, that trend is there, increase and decrease. There is no constant increase, there is no constant decrease in the number of population. Yes. Okay. So now we have the value. What we are doing is now we are playing with this data, average X and average Y. Okay. So you have this value 345463. That is the first increment that we have calculated from the population. Then we have calculate again the increment or decrement from the population data. So here we have X increment and Y value. So Y or X, these two value we have calculated and we have averaged it out, and we got two values, X value, X average and Y average we got. Now we are playing with only this two data for our question. So first is like you have to calculate the population in 2021. How you do 2021? So what you have to do is, yes, number of decades is one, because we are when we take it like from 2011 to 2021, it 10 years come. So then when we convert into decade, it is like 10 by 10. It become one decade for 2021. So for example, if you take 2031, how what is the decade? When you consider 2011 to 2031, 2, n equal to 2. So if it's 2041, then when you 3, yeah, that is right, 3 decades. So if this have any doubt, anyone has this doubt to how to calculate the decades, this is easy, right? Finding the number of decades from the last, no doubts. Okay, fine. Okay, now what is the population in 2021? So how do you calculate? So what you have to do is, you have to first see the population from the analysis data. You have to go to 2011. That is the last mentioned data. That is known. So that value is here, 2585862, right? Then that is the last known data from your base, like from your analysis. Then you have to take the x average value. So this average value is 34546 3. Then you multiply with n, number of decades. What is the number of decades here? Is 1. Then, so we have considered this x average value. Now we have to consider this y average value. Here, what we have to do is, you have to take the number of decades, that is here it's 1, into number of decades plus 1 divided by 2, then the whole multiply with y average, that is 87729. Okay, so if you do the calculation, what is the value you are getting? So first you are taking, yes, that is right, 3019054, that is right. So that is the for year P 2021. What is the formula here? This value. 1 means here N. What you have to do is, so I'm just writing the formula. Formula in the sense non, like you can easily understand this. You have to calculate 2021 number of people. Then the last non value, 2020 2011 value, So you just add with the value x average. You have calculated the x average, and then multiply with number of decades. Then plus what should you do is, n into number, this is number of decades, into number of decades plus 1 divided by 2 into what is your y average value. This is the formula. Got it? Got it, na? Should I repeat? Okay. So then you can calculate P. What is the number of people in 2031? Calculate what is the number of people 2031, and what is the number of people at 2041. Yes. 3539. 975. Yes, right. 2041. Yes. Yes. N will be, see, 2031, the you have the known value of last year 2011. So you calculate how many years they are there between 2011 and 2031. So you get 20 years. Yes, yes. Yes. No, no. You can take, this is the basic value. Like this is like the question they have given, but the basic non values that you, from your survey that you got is only this much value from 1961 to 2011. You got it. See the here they have what they are doing is, see, from 1961 to 2011 the survey is taken and they have calculated the population. Now if any years they have given, even any future year they have given, consider the last value which is known by the survey, that is 2011 in this study. Not getting. uh, so what is the value you are getting in that if you do like that? Can you, different answer, what is the value you are getting? So can you tell me the value for 2031? Then you have taken the years like one, right? Decade you have taken one. Did you take decade one? Yeah, but see what they see. This is just a question. This is like the they don't we don't have the other years. Just these much years it is given. So if it is, this is the basic value that we are not predicting. This is not prediction. This is like actual calculation. Okay. This is the survey, the clear cut survey. They have calculated the number and they have given. And the future years we don't know. Got it. 2021 and 2031 we don't know and we haven't taken the survey. So that is our prediction. When we use these values for the calculation, you should take the values which is already surveyed value of population. Okay. 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 But those values that you have calculated, now it is not from the survey or something, right? That you have calculated. I am also I am teaching this from the salt like questions from the that Kharagpur only, IIT Kharagpur questions. So in that they have considered this only 2011 only as the base. So maybe if you calculate, if you are getting same answer, what is the answer you are getting? Because in the previous arithmetic increase method and uh, matching na. So in their, yes, okay. So in IIT Kharagpur, in their booklet which I have referred, they have considered the 2011 value for the as a base. They haven't increased the years. Yes, yes. Arithmetical yes. It is constantly increasing. Huh. Yes. Yeah. Okay, okay. So, in this question, which I referred is from the IIT Kharagpur booklet. So, in that, they have considered 2011 as the base. So, okay, then I will also inquire about this. In what text have you seen that? Can you tell the name of the textbook? Okay, okay. I will refer the book. So in that, they have included incremental increment method or arithmetic increment method. So you have to check that. I will also check. But from the booklet which I am teaching you, they have considered 2011. Okay. So have you guys attended the previous sections of other people also, right? So in that they would have teached this question, like this type of question, hopefully, right? No, like they also consider this to like I mean the previous value, or they have considered jumping to the next value they have calculated. Anyone remember? Okay. Okay, fine. I will again inquire about that book also, which I am teaching also from the booklet only. I will inquire about that. Okay. Okay. The guy who asked this doubt, na, can he speak something like you got clarified or something? Okay. Others? Hear me? You guys can hear me? Okay, okay. Okay, we'll go for the next question. That is the sewage flow quantity estimation. So, in here, we are going to learn about this term, which is infiltration flow rate. What is infiltration flow rate? So, here, you know that I already, in the previous class, we have discussed when there is a huge flow of rainwater, there is, yes, right? This, okay, okay. Yes, last only, right? Last year only they have, yeah, last year, because others that we are predicting, that is not the calculated one. I hope that yeah, the difference. Uh, four method, yes. Uh-huh. Okay, okay. Yes, yes, yes. I will also refer that. Yeah. Yes. Thank you. Okay. So now what is infiltration flow rate? So infiltration flow rate is that the groundwater or storm water can infiltrate into the sewer system through defects or cracks or joints in the pipes. So that will actually, increase the amount of water that is flowing through the tubes. So this will again, what happens from here, this infiltration will will cause a loss of groundwater, which is good water. It will enter into the sewage and it will also get wasted. Also this will affect the stability of the system. the cracks which is already in the tubes will again, the crack can elongate and it will spread through the system, and it will ultimately it will destroy the flow. And this will also cause, we have built the this the pipes according to the amount of wastewater generating as per our calculation. So we know that from the number of people that is living in a particular area, we have calculated, okay, this much value of wastewater is going to generate for this much years, and accordingly we have built the sewer system. But when there is a unpredictable rain or some other flood, rain also, you can say that, okay, for example, if the dam breaks, or if some other reservoir, if something happens, the it can change the way of their flow, and it will come into the sewer system, and it will increase beyond the level of the capacity, and it will affect the system. So this infiltration, we have to calculate infiltrate how much infiltration has happened to the sewer system. So that is a important parameter that we have to understand, because that value will help for the future correction of the sewer system. So now, yes, anyone speaking? Yes. No. Okay. So now, central pub. So here we have to go for some few problem for this section also. Hope this type of question also you people have solved, right? The maximum. The Here we have to calculate the maximum. They have given the annual flow of the from a city. They have considered how much flow of waste is happening, and we have to calculate the annual average daily flow, or we have to calculate the maximum daily flow and maximum hourly flow. This type of questions have you solved? Okay. Now we'll before going into this question, I will just show you a small example where a small problem we will solve, that will help to understand some, going to that question. So first of all, we have to calculate the infiltration rate. So first of all, what you have to do is, for a city, I think if you have seen the, okay, I don't, okay, I will solve here. Can you see the screen? Yes. So here you have to calculate the sewage estimation. Sewage estimation, how we can estimate the sewage. Then we'll go for the infiltration after that. Okay. So now, in a city, number of people, we are considering 10,000. Then average water consumption, 200 LPCD. Then 80 percentage of water consumption goes to sewage. What happens to remaining 20 percentage of water? Can anyone tell me? So here they have considered 80. Sorry. Yeah, the drinking we are utilizing, and also there is some loss happen due to, we have discussed on evaporation, and some loss also happens, right? So 80 percentage of the water is consumed, ca- this 80 percentage of the water consumption goes to the sewage. We get 100 percentage water. If you take that particular value, 80 percentage of the water which is after the consumption, what you said is true, that we consume some water, some water will go like evaporation, like that there will be some losses happen. Remaining 80 percentage from the what we got, 80 percentage of water is going back to the sewage. Then the total number of people is 10,000. Then average water consumption is 200 lpcd. What is lpcd? Liter per day. Okay, how you convert this to mld, million liters per day? Yes, divided by 10 to the power 6 or into 10 to the power minus 6, you can tell. That will convert into mld, right? So now this, but I think this you can solve. Then calculate what is the average hourly flow. Hourly flow in the sewage system, you have to calculate in meter cube per hour. What is the hourly flow and what is the maximum hourly flow? What is the hourly flow and what is the maximum hourly flow? Meter cube per hour, you have to calculate. And what is mean by maximum hourly flow? This is a sewage system, and here the water flows, and there will be lot of, this is a, you can assume a city, and you can see that in, when you analyze the diurnal variation, that is when you take it 24 hours, the flow of water through this, maybe like it, the flow will vary in 24 hours. So we, this is 24-hour means one day. What happens at night? If you consider at night, most people will you know sleep, or the activities will be minimum. So at that time this flow is minimum, right? Can you relate that? Yes, so at daytime, if it's a city, in office hour, this flow is maximum. So accordingly, you are calculating the average hourly flow through the sewage system, and what is the maximum hourly flow. So how do you calculate this? So for that, huh? Yes. Huh. So here, we, it is already noted that number of people it is noted. So yeah. So you know how much, how many, like how, you know how it is hard. Then average water consumption is also they have given. Now you have to calculate the, how do you calculate the average water flow through it, and then how you convert the average flow through it through the average hourly flow. So now we'll go see that, and then I will give you another question for you to solve. Okay, here. Okay, so here first we can calculate average wastewater flow. We'll calculate. So average wastewater flow, which will be, so who's unmute? Can you please mute it? So what is the average consumption of water? Average consumption of water is 200 LPCD, right? Then you know how, what is the amount of water which is going into the sewage. It is mentioned from the consumption, 80 percentage of the water from the consumption is going into the sewage, right? So then how do you calculate? Then you have to multiply this value LPCD into zero point 0.8. So this much water, this is the average flow of water, and then you know that from this particular amount of water, 80 percentage is going into the sewage. So you are calculating by multiplying the percentage into the average water flow. So then, first of all, you can convert this into MLD, that is 200 into 10 to the power minus 6 MLD, million liter per day. Then you multiply with zero point 0.8. Then what is the value you get here? Yes, 1/6, then 160 into 10 to the power minus 6 MLD you get. So now you convert this liter into meter cube. How do you calculate that? Into 10 to the power minus 6 into 10 to the power, you convert liter to meter cube, that is 10 to the power 3 you will do. So then here, this is like, then yeah, million liter. So here the we have, yes, yes. So yes, per capita per day is there. So you have to multiply all with the, yes, just just one second. So, but when we do this, what you are getting? Then let me convert the units. Here it is 160, then into 10 to the power minus 3. This is million meter cube per day. It won't, just give me a second. 10 to the power minus, yes. So you can, yeah, here what you are getting is 160 you are getting, but you have to multiply with number of people to get the, you to eliminate the capita, right? What you're saying is that point, right? Yes. So you have to multiply with 10,000 to get the to eliminate this capita, like that is the per number of people which is available in the city, right? Okay, yeah, right. Yes, yes. 10 10,000, and the value will turn into 1.6 MLD, right? So then you have to convert into meter cube per day. Did you calculate this? That is, here you have to calculate 200 LPCD into zero point 0.8. It is the percentage of water which is going for the sewage. Then you have to multiply with the number of people in the city to eliminate the capita. Then here you have to convert this LPCD value into MLD. That is, you have to multiply with 10 to the power minus 6. Then the final value will be from here 1.6 minus 1 1.6 mld. Is this right? Right, right. Okay, okay, okay. Then everyone got this? Sorry, did you get this answer, everyone? Okay. Then how do you calculate the average hourly flow? So how do you calculate from here? This is per day. So how do you calculate? Yes, 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 yes. 10,000. Yes, 10,000 is the number of people. Okay, okay. Now this is one question, that is average hourly flow. Then maximum hourly flow is also there. So now you have to calculate average hourly flow. Sorry? Huh. Anyone has doubt? Huh. Yes, per day. Per day. Then you per hour flow rate. Then this is in liter. So you have to calculate this. You have to convert this liter to meter cube. So yeah, you can calculate per liter also. So you have to calculate in this unit meter cube per day, meter cube per hour. Okay, so you when you convert this into meter cube, it will become 1.6 into 10 to the power 10 to the power 3. So that means 160 right? Yes. Yes. So then that is the 1 day value. So when you convert into uh, like hourly, that means you have to divide it by 24, right? Then for the maximum hourly flow, you have to take this hourly flow and you have to multiply with the peak factor, right? So got it? So here we have got the 1 day full for the 24 hours. This the flow we got 1600. To calculate the hourly flow, we have to divide it with the 24 hours. So this value, got it? Anyone got this answer? Peak factors here it is 10,000. So for the till 10,000, the peak factor is uh, 3. 3. So peak factor, I have see here from the population. This is the peak factor. Depends on the city and the even the region also. So peak factor is the average flow rate through the sewer system divided by maximum flow rate. So from number of peoples which is occupying in an area, it is already they have calculated and assumed these values we are assuming. So yeah, yes. So here till 2 lakhs, no, 20,000 it is 3 peak factors. If the number of people is till 20,000, the peak factor is 3. If the number of people is 20,000 to 50,000, it is 2.1. Then till, yes, got it na? If it's about 7.5, it is 2. Got it? Okay. So this answer, this question, where is, oh, it is gone, I guess. Uh, this peak factor they have, I think this is not from it I think it is not only from the population, it also depends on the area, like where, if, even if it's a city or if it's a village area, so it differs. So this I think they have considered on the uh, survey, I guess. Okay. 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 In the you are telling it is on the basis of the they have assumed some area and they have analyzed, right, that I mean this they will be some of the assumptions are there, right, like that. Huh. Ah, two. Okay. Okay. So so you are saying this equation which I have given you, like it is varying, you are saying. Huh. So what is the difference you are feeling? I didn't understand. Huh. Like you are saying that they will be like number of people and the they have taken the that boundary values they have taken like that, right? Huh. So it depends on so yes, yeah, that is right. I think, yeah, I have taken from the material only these values, I think. Yeah, So it is depend on the particular. If you take some other city and the values are differing, so in this example is given on the basis of the lecture that you have taken, right? So in that they have given, yeah, what one of the guys telling na, this the table that it is mentioned. So this table is not, this is not mentioned in the material, right, which you got this particular data. So you, uh, okay, last large survey data, so that is 2011 till 2000, yes. Okay, so yeah, maybe this value can vary on the basis of the population difference. This is not the, I mean, this is not the constant value that you have to take it. I hope they will give the chart like this. Then you have to, then they will give the boundary conditions. Then you have to calculate the peak factor. They also will give the total, means maximum flow rate and average flow rate also they can give on the basis of the amount of sewage that is generated on that particular period of time, right? Okay. So this value have you got? I think I lost that page. Like what is the value you got? Average. What is the hourly flow it is coming? Maximum flow is 200, right? Average is okay, yeah, 66.6. Yes, that is right. So can you share the screen of yours which you sold and show to others? Like because I have lost the, okay. So anybody has done? I think you guys already done, right? Can you show it in the screen? Can you share the screen? Okay. Anyone? No? Anyone can do it? Okay. Otherwise, I have to do it, write it again. That's why. Oh, okay. Thank you. So I am stop sharing. Then only I think you can share. Chitra and Divyani, you people also have solved, right? Solve problem. Okay. So this way only it has to be sold. So what this here, what you got? 66.6. And here it is 200 meter cube per hour. Meter cube per hour. Okay. Huh? Huh? Drain capacity in the sense, what have you like? Huh? Huh? Huh, that you consider. Also there is one more thing comes, which is not able to predict, is the rain, amount of rain that you get. Huh. So the maximum rainfall data for a particular area has also to be considered for the drain, because that not be added directly, but maybe the average can be taken, because average we will get the rainwater in the we know, right, the centimeter we'll get. So then, yeah, so then from that you have to consider means you have to calculate the volume, amount of water that you get from rainfall. So accordingly you should build bigger one to accommodate that water flow also. Okay. 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 You guys got it, this one? Yeah. I think Divyani. Okay. So now we'll go for the few easy, like we'll go for some other questions that which is easy to understand. So for if you consider a wastewater, so what are the important parameters we have to note it down to understand the characteristics of the wastewater? So these are the important characteristics, which is pH of the water, dissolved oxygen, turbidity, temperature, and conductivity. So here they have given one question. You understand the color in a water can be directly measured through what? So here they have given four options. A, solution pH using pH meter, absorbance using spectrophotometer, weight analysis using gravimetric method. D is all the above. Option B, absorbance using spectrophotometer. How do you understand that? That what is this exactly? So how the measurement is taken? Anyone know that? Because um, if you take, you know that water. 1 minute. Okay. So you already know if it's a fresh water, you know that a water which is very clean. I mean, like a glassy water. So if the light pass through a glassy water, how it behaves? Huh? So glassy water means mostly the okay. I'm not okay. So if it's a glassy water, if yeah, there in pure water means there is no that waste things like the more the ions are not more ions are not present, it is much more clear, so the light easily pass through, right? So if there is a suspended which is very, a very turbid thing is there, then what happens? There are a lot of matter which is present in the water, it can absorb, the light is absorbed, and the data, the light which is passing through the this particular solution will be less, because most of the light is absorbed from the elements which is present here. So you heard about this extinction coefficient. So that is called, it is like when you pass, it will pass through it. If it's passed without any disturbance, then that means it is like there is no disturbance inside the solution. When there is more and more elements, more and more like foreign things is added to the water become more turbid, and there is the things are inside which can easily absorb the light, which doesn't allow the light through, which is passed through the medium. So from this particular data, we can calculate whether the water is very, it is, the color is light or it is very dark. For example, you take a water. Here you have a water with you take a very clean water from well. So this is well water. So here you take a water which is you have some you say that this is pond you can take. Also you can also add some more things which is very, which can absorb the light. What you can say, carbon, you know about carbons, black carbon, black carbon. Yes, they absorb much of the light. So here it will just pass through. So according to the absorbance data, we get absorbance, we can get to know whether the sample that we got is the fresh one. I mean, like is it less polluted or it is highly polluted. So that we can use from the spectrophotometer. Now, what is nephelometer? Have you heard of nephelometer? So why here? You know that pH, turbidity. Yes, right. So, what exactly they are taking is that absorbance data or the transmitting data or the scattering data? Which data they are taking to scattering data, right? So here we are taking the scattering data. This is our particular sample that we need to measure, and we have to calculate the turbidity of the sample, and the light source is passing from here, and we'll calculate, we already get the information about the transmitted one, and some will transmit through the water, and some, what it is called, it will have different, there will be a presence of a lot of material here. It will scatter the radiation, and then it will get scattered, and we can collect different scattered data. So different scattered data we get, but we get the scattered data which is 90-degree to the platform. Then we collect the information. From that information, the data is analyzed for the turbidity. In for the nephelometer, the main parameter that we are considering is the scattered light. Okay, so next, so emerging pollutants in yes, 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 yes. So emerging pollutant yes, yes. Okay, so I don't know the conversion value. So you're saying the turbidity according to the matter which is inside that, it is can be calculated like milligram per liter, right? The amount of turbidity. So, so the conversion value, I don't. If the higher value of milligram per liter you are getting, then the end, like NTU values also, the range of NTU value I have to check. Huh. Huh. Okay. Huh. Yes. Okay. 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 So, I think when I check, it is like the range is there. Like, you know that for some measurement, it is like the value is differ from 0 to 1. So we you have to take the one is the maximum, and all other values come between 0 and 1. So like that in nephelometer, the turbidity it is range is between 0 to 40. Okay, so then you have to, I think the that is the maximum, that is the range possible in the machine. So the maximum value 0 to 40. When I checked, it is like that. So I can check again, but I don't know how to convert it. Yes. So what is the limit of the range? 1080 also. Okay, then that means yes. So that means there is no like the conversion factor. I don't know now, but what is the maximum value you are getting with the instrument that will correspond to your data which you calculated by a milligram per liter. So let me see. What is the conversion? You are saying the how to convert the milligram per liter. Okay, that okay. That I have to check. That I will check. Huh? Yes. Okay. 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 So yeah, that might be you're from this field, like right? Hello. Yeah. Okay. Okay. So, but you can't convert, right? So that means that you can't convert. Okay. So that means that you can't convert. If you take some random okay. But for the other different type of wastewater, it is not possible to convert. The conversion is not possible, right? Depends on the water, it is saying, right? That was the statement. Okay. 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 Okay, that will be correct, sir. So I will also refer, and next class I will come with this particular thing. Okay, so the next question: have you heard of forever chemicals? Forever chemicals. What is called forever chemicals? Forever chemicals. Forever. This term, anyone heard of forever? Okay. Okay, so nobody heard of this forever chemicals, right? Okay. So now, Okay, so now we'll just, what is emerging pollutants? So here the question is, what are the emerging pollutants in water include? Different options are given. Metals such as iron, manganese, and arsenic. B, pharmaceutical and personal care products. C, organic effluents from chicken and kitchen. And D is all the above. What is the answer for this? B. B is the answer. Pharmaceutical and personal care products. Okay, keep this mind. Next, we'll go for what is called forever chemicals. So, this forever chemicals, have you heard of PFAS and P4? This two word, PFAS and P4. So, this is like, here this is the very, this time this is hot topic, because this particular chemicals are not easy to break or degrade. It will just stay there and it will cause a huge health impacts to the human body. And the effect of these particular chemicals are not at all studied deeply. And so that there are a lot of things, even when you take your daily care products, this has PFAS. So here mainly this bond, CF bond. Have you know that the what is the characteristic of this bond, CF bond? CF bond. No. So this bond CF is very, very strong. It is very tough to break it. So many of the, this is also a hydrophobic bond, hydrophobic functional group. So due to this hydrophobicity, this particular chemical is used in many different type of things in the daily care units. You have seen about waterproof clothing. Waterproof clothing, have you heard of this thing? Waterproof clothing. So in this waterproof clothing, this particular element is coming, CF. So this is very dangerous and it actually cause health effects. So this even include our daily care products for the shampoo and face washes, and also when we talk about different uh, also there is, we use the uh, pans for our kitchen, so kitchen utensils also, non-stick pans that we use. So these all thing has this particular functional group, that is PFAS and P4. It actually taking the industry in all our daily care to even to the kitchen also. This particular PFAS and P4 is there. So it is actually very hazardous to human beings, which is not yet fully studied. And now this particular topic got more attention because now studies are going on and it is started, and the impacts of this particular functional group is detected. And you may know about different polymers. You guys already know about polymers, and from this polymers, PVDF, you guys know PVDF? Anyone heard of this PVDF? Yes, yes. So this PVDF purely, it is mainly, this particular polymer is used for the water purification technique or membranes, because of this hydrophobicity, and this is mainly of CF group. This particular, because of this thing, PVDF is banned in many countries. In India, there PVDF is available. PVDF is still available in India. In many other countries, it is banned. So in India, mainly we are not using PVDF. In case of PV, we are using PS polymer. PS, you have heard, right? Polyether sulfone polymer. So this is we are using, but PVDF also in for some membranes it is using, but PVDF is very hazardous. And other than this thing, there is one more term that you have to note it down: microplastics. What is microplastic? Yes. So yes. So the microplastics can come even from our clothes also. So, yes. So this microplastic is actually getting higher and higher concentration in even in the environment in our surroundings. This has also has a great health hazard. So, have you heard of microplastic? In even when we use plastic bottles to drink the water also. So even there are different studies which have shown even our blood also has some studies in blood also this microplast is detected. And also uh, for the baby newborn babies also, when they take intake from the mother from the milk breast milk also, this microplastic have detected in the breast milk also. And also you have seen in nowadays we also have drink this, there is one particular glass, even if you go to uh, CCD, that is coffee cafe day, and if you go different, there is different industry, for the coffee and tea, they'll give them plastic, no, the paper cups they say. Even that paper cups is not fully paper. Okay, so there is amount of plastic is also there. Even from that also we are getting, or also we are also transporting this microplastic to different directions. So these all points keep in mind. From next class I will include questions from these all parts: PFAS, P4, and this microplastics. Okay, yeah, PFAS here. See here, polyfluoro. Actually, P4 is a variety from a subgroup of PFAS. Okay. Huh. So I will upload this slide in the drive, so you can download this, and I will add more. Yeah. So emerging contaminants. So so you know that pharmaceutical waste, antibiotic, and disinfectants also from the pharmaceutical waste also. This water from the sewage water you can find the content of pharmaceutical waste also. There is one more term that you should know, that what is when we take antibiotic for a longer time, then there is a presence of super bugs. What is super bugs? Have you heard of this word? Yes, yes. So that is also a impact of that antibiotic. So these all things which we use daily, we can find the content in the wastewater in our sewage system. So this keep in mind. I will add more questions and tell you next class. So this also okay. I will discuss this last question. Which of the following causes the temporary hardness of the water? Anyone can answer? Yes, that is right. Yes, 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 that is right. Okay. Okay. Next question. Dissolved oxygen can be consumed in stream by four options are given: photosynthesis, decomposition of organic matter. Yes. Then, sorry. No, this is decomposition of organic matter. B. Mainly. Yeah. It's okay. Next, which of the following statement is not true regarding dissolved oxygen? A. Cold water holds more oxygen than warm water. B. In surface water bodies, photosynthesis activities may lead to hourly variation in DO. C. Water holds more oxygen and higher altitude. D. In larger, deeper rivers, some Vertical stratification of DO might occur, which is not true. Find the option which is given here. Which option is not true? Which option is not true? Is it? Yeah, right. Absolutely. This C is wrong. Because cold water holds more oxygen, that is well aware, because when the warm water is there, heat is added, that more kinetic energy the water has the tendency to escape from its interface, and it has more vibrational phase, it when it get more heat. But when it cold mean it's more denser and it can hold more oxygen. So then second is in water, in surface water bodies, photosynthesis activity may lead to hourly variation in the dissolved oxygen. That is true, because in water bodies we know that photosynthesis in the water plants, photosynthesis happens in the daytime, and the photosynthesis also depends on uh, the solar radiation availability also. That solar availability will vary from morning to after evening, and around it depends on the area also, around 1 to 2 p.m. it is the most the maximum solar heat that we feel. So depending on the hourly variation, the photosynthesis. Yes. Yes. So at night, the these photosynthesis will stop, and then the dissolved so these all parameters will give you not a constant dissolved oxygen generation in the day, means 24 hours, the variation will be there. So in the D, in larger, deeper rivers, some vertical stratification of DO might occur. Okay, what does that mean? So this is the river picture. This is a rough picture of a river. You can see that for a river means it is not a single body. So there will be different density regions and temperature regions will be there. So you can see that the top region is mostly more, temperature is very high there, and then you can see the down area, which is when you go down you see that it is more cold. So more cold will be there, and also in the bottom region there will be presence of microorganisms. So these microorganisms will take more of oxygen. So this will vary the amount of oxygen. When you take a graph, the oxygen variation from the top of the water body to the bottom of the water body, it won't be a straight line, it not a constant. It will vary from top, layer by layer. So this one I will give you some examples by different namely rivers, and I will show you next class for different rivers how it varies, also to the ocean how this vary. The two graphs next class I will show. Okay, so any doubt in this class? What is aquaculture? What is that? Is aquaculture only, right? So the okay, aquaculture means we are growing the plants on the, yeah, no, we are using fishes, right? So that means, so that we are creating a artificial source, water source, right? So you're saying artificial water source, how the variation of oxygen will be there, right? So in the artificial, okay. Okay, so I never thought of it, but if there is a presence of, in this fishes also, the region where it can travel. So some fishes that we normally cultivate, that is for our human purpose, right? It will always stay in a region where we can catch around. It won't go very deep. So in this particular region, if it go deep, the different layers of ocean, right? So when you go to the ocean, the salt variation is different, and even the temperature is also different. The topmost layer has the temperature which is suitable for the fishes that we are growing, and this nutrients which we are providing, also there are photo plankton also, and some small phytoplankton. So this phytoplankton which is needed for this fishes is staying most of the region is in the top layer. So depending on that, the oxygen will be higher in that particular region, and when it goes down, that oxygen availability will decrease. So okay, that I will write it down, and next class I will tell you if something additionally I can add. Okay. Any other question? Yes. Yes. I will discuss you about the oxygen. Yeah. I will discuss about this one, and one problem and other theory I will take next class. And this thing I am confused on this thing nephelometer thing what you have asked. So that when I will clarify that. Which laboratory? Okay, laboratory procedure you need. Okay, okay, that I will discuss, and I have this also in my lab, so I will discuss on this also if you want photometer. This, yes, huh? So I haven't done this experimental one for the pH. We normally use conductivity. We have conductive meter. Yeah, even we have pH meter also. So we will take the liquid, and we will dip. We have the electrode, and we will dip in the liquid, and we can measure the things like conductivity. We can measure TDS. We can measure directly, but the working principle I have to refer and tell. And turbidity we don't have. Temperature is easy to measure, and dissolved oxygen there is a method like we in a laboratory we can collect the water, and we can use some chemical to precipitate the water, oxygen with the chemicals. Then from the measure weight of the precipitates we can calculate the amount of oxygen it was stayed in the water. Okay, this pH and dissolved in the laboratory one, right? Yes. Alkali. Huh. Okay, okay. Huh. That I can explain you. Yes. Something else? So this is clear, right? What is the difference between municipal wastewater and the domestic wastewater? Okay, so this I in the previous class also there was discussion. What is the difference in domestic? So domestic means which is from the home only. So which is mentioned in the screen. You can see the screen, right? So, but in the municipal, it is mainly, the education institutes will be there, and also hospital waste, and hotels will be there, restaurants will be there. These all waste also considered, and small scale industry. But there is industrial waste specifically, that is industrial waste, but here we are considering small scale industries also, these hospital waste, and from the big educational institute, restaurants, the saloon and laundry waste, these all things also together considered as a municipal. Okay, got the difference? Okay. Okay. Any other question? Huh. No. Okay. Then we'll end the class. Only this thing I'm sorry about the this one, this NTU. So that one we'll Discuss next class, nephelomy. This also you need the laboratory one. That what you are telling. This also you need, right? Turbidity. Ah, yes. Yes. You will make sure that even the system will give you the absorbent. If the system will give you, yes, system will give you the plotting, the scattering data you will get from the system directly. Only the conversion you have doubt. Okay, that I will clear. Okay, okay. Next class I will update. Okay, okay. Thank you, thank you. Okay, we'll end the class today. Thank you. Good night. So if any doubt is there, okay, okay. Good night. Shit, oh my God.